Docket 16-03536 in the matter of the application of Rocky Mountain Power to implement programs authorized by the Sustainable Transportation and Energy Plan Act. And today's technical conference deals with the Pacific Coast proposed solar and battery storage project. We do have a few people on the phone, and we'll have them introduce themselves in a minute. I'm going to circulate a sign-in sheet, and so if you'd please sign that, that would be great. And we'll first go around the room, and then we'll find out who's on the telephone. So do you want to start up over there?
Sure. Lori Shelton with Public Utilities.
Jordan White with the Public Service Commission.
Justin Jetter with the Division of Public Utilities.
Robert Moore with the AG's Office Consumer Services.
Rex Olson with the Office of Consumer Services. Bela Bostog with the Office of Consumer Services.
Peter Ashcroft, Office of Energy Development.
Kelly Francona, Utah Association of Energy.
Kathy Van Dane, Breeze, Utah. Brenda Salter with the Division of Public Utilities.
Jeff Einfeld with the Division.
Philip Russell, Counsel for UAE.
Yep, Utah with the Division of Public Utilities.
Bob Davis with the Division.
Eric Martinson, Public Service Commission.
Bob Lively, Rocky Mountain Power.
Dave Clark, Dave Clark, Public Service Commission.
Michael Shea, Gila, Utah.
Jamie Dalton, Public Service Commission.
Dave Thompson, Division.
Steve McDougall, Rocky Mountain Power.
Daniel Solander, Rocky Mountain Power.
Rohit Nair, Rocky Mountain Power.
Douglas Marks with Rocky Mountain Power.
Ian Hogue with Rocky Mountain Power.
Carol Revelt, Public Service Commission.
Artie Powell with the Division.
Thad LeVar, Public Service Commission.
Carolyn Roll, Division. Sophie Hayes, Utah Clean Energy.
Okay, and if the people on the phone could introduce themselves, that would be great.
Nancy Kelly, Western Resource Advocate.
Ken Wilson, Western Resource Advocate.
Cheryl Marie, Office.
Okay, and I'd like to let you know that this is technical conference is being streamed, and we do have microphones up on the table. If you're going to ask a question, we'd appreciate it if you speak loudly or come closer to the table. That would be great. And with that, I'd like to turn it over to the company to have them make their presentations.
All right, thanks. So we're going to talk about the proposed battery and storage project with some solar components to it. So we've got a short presentation. We're going to go through an overview of the project, what we're proposing, what we're trying to do with it. And then when we're done with that, we did receive 27 informal questions that were submitted. Hopefully through the presentation we'll answer most of those. But I've also listed the questions at the end of the presentation so that we can make sure we've covered all those and also any other questions that may arise, that we can get those answered as well. So it's an open discussion. It's supposed to be an informative to hopefully alleviate a lot of questions surrounding this. So what we were looking at is what we know, the grid's evolving. We're looking at new types of renewable energy. We're looking at energy storage as a way we can actually use that to help us with the renewable energy, and that's the major contributors to the grid that we're going to see in the future. What we've looked at in different kind of storage solutions, the batteries right now that we believe for the state of Utah are the best storage option we have. I mean, we don't have a lot of pumped hydro availability, etc. So what we're looking at is what can we do with some proven innovative technologies in order to offset some traditional infrastructure. And by traditional infrastructure, I'm talking about what we used to do with the poles, wires, and cables. We actually started down this path a few years ago looking at how can we use these new technologies in that regard. So we had some background information prior to the step being passed. So what we did is through this exercise, we actually found what we believe is a very logical location to do a pilot program to test the battery storage and also its integration with the solar system so we can test the interaction. We were fortunate enough that we actually did find a place that we can actually solve an operational problem with the pilot today. So that's what we're looking at. The purpose of the program is, like we stated, it's a pilot project for us so we can become familiar with the operation and the integration of these technologies to give us the experience we need when we start going larger scale, that we've got a better understanding of what it is, how it works, what the controls are required, how we can adopt that into our system to work and to work well. And of course, we're looking directly at the interaction between energy storage and the renewable energies. So what we will be building out of this whole program is we've got to develop some common practices for how we operate it, how we integrate this stuff, how we troubleshoot it, how we get the information back into our system to use it as most efficient manner that we have so we can keep going with our reliable grid that our customers have been used to and are getting, looking for other solutions as well. So when you look at what you're doing with energy storage, so first off, this is an energy storage project was the first off thing. And if you haven't picked it up, this is a pilot, so there's a lot of ifs for us as well that we're trying to solve with it. But mainly what you do with energy storage is you can use it for renewable firming. So you have the clouds come by the solar panels, it kind of hesitates a little bit in its production. We can release some energies from the battery to firm that out to steady state it. We cannot use it like we use for spinning reserves though. So that's what we mean by renewable firming. The wind shifts a little bit, the solar becomes a little unreliable, we can help do that. The other thing you can do is you can do peak shaving or load shifting, which enables you to not downsize, but defer investment in larger transformers, poles, and wires for a period of time until you can no longer do that with storage. And you can also do it for voltage and frequency support out on the grid. So those are the kind of the main three things that we've seen that we can do it. We, as part of this project, we actually focused more on the peak shaving and the voltage support. The others are side benefits that we'll get out of it, but this is what we were looking at. So like we talked about, peak shaving, that solves thermal overload problems. So a conductor or transformers overloaded, you either have to replace it or else you have to reduce the load on that. It can also help with voltage issues, so that's part of what we're doing. We actually looked at a problem that was almost purely voltage support, because voltage support, we're talking about benefits not related to thermal overload. Although you'd say, well, aren't they the same? And the answer is not really. If we didn't have bandwidths with which to operate our voltage in, you know, we can take the thermal conditions a lot higher than they are today. So there's a transmission line that we've identified that will become non-compliant to the ANSI standards in our forecast about 2019 at the current load growth that we're seeing in the area. Okay. The other thing we did is we looked at the interconnection costs for the battery, and it is cheaper to do it at the distribution level on the low side of the power transformer rather than to interconnect it at the transmission level. There's a lot of costs associated with that. So that's kind of how we selected the project. What do we do here? Did that a few minutes ago. So what we're proposing here for the technology is we're looking at a 5 megawatt hour battery storage. It's rated at 2 megawatts of power, 5 megawatt hours of power output. We're actually looking at deploying it in 2 stages. With the first one, with the 2 megawatt hour battery being put in 2018 to solve the issue for 2019. What this will do is allow us to get some experience with it, and then if the load forecast keeps going the way we see it, then we're going to supplement that again in about 2020 with another 3 megawatt hours of storage capacity. The other thing we're looking at is because of the interaction we're looking at between storage and renewables, we said this would be suitable. We're looking at a 650 kilowatt rated PV solar generation farm. Now this became actually, in the course of the analysis, a fairly economical one compared to the alternatives. So we did look at the alternatives for the transmission line of reconductoring it in stages to help us with the voltage support. That was a pretty pricey option. We looked at putting a whole new substation in to give us some better voltage support. That was also a very pricey option. And then the other thing we looked at is what would we have to do with just a battery with no solar? And you're looking at an 8 megawatt hour battery that's just a little bit more higher cost than the combination of what we proposed here. So just for information, the transmission line we're talking about, when I talk about voltage support versus thermal overload, this transmission line today is only loaded at 20% of its thermal capacity. But because of its length and the voltage drop across the length, I can't hold that voltage at the end of the line anymore, feeding a distribution substation. And so the way we can do that, we've done a lot of both distribution level capacitive correction, we've done some transmission level capacitive correction at the end of the line. We'll pretty much hit the end of that. So we've either got to do something with the conductors, or we've got to do something with some new technologies. So that's how we kind of came to that conclusion. So it gets that way. So we talked about what the functions of
Quick
each.
question, the 3 megawatt addition in 2020, do you envision that being a step project as well?
Yes. So we've got it all in. We're looking at, because of the 5-year length of the STEP program, so we're building it in there. If the forecast changes a little bit, the size of that battery may change. And the other thing is, we put together the proposal based on what we know, what we talked about with other engineers and other utilities. When we take this out for bid, we're going to be talking to a lot of people, and they may come up with something that's slightly different than what we propose, because we're actually looking at, we know we need a truck. We want you to tell us what that truck's got to look like. So we want to look for the most efficient, optimized solution we can get. So a lot of the answers may change through the process, through the RFI and the RFP process. So
Does that include the capacities of the, for example, how does the PV system relate to the battery system?
you want to answer that one over
Sure,
here?
so when we looked at,
Could you repeat the question, please?
This is Dave Clark. I'm asking about how the size of the PV system relates to the battery storage system, and whether
Thank you, sorry for interrupting.
and whether that might change in the design as the design's refined.
yeah, that's a good question. So what we did is we looked at the loading data for the area, what kind of loading data we have. We looked at 2 options. Number 1 option is, okay, if we have a battery-only project, and what size battery we would require, what different charging times and all those things. And the second option, what we looked at is, okay, can we decrease the size, and to what amount the battery size can be decreased by adding a solar component to it. So that's where we did certain permutation combination to figure out at what size solar level we can bring down the battery size. And that's why you would see 2 options over there.
Okay, so in combination, they're solving the problem.
Exactly.
Okay, I understand.
Yeah, like we mentioned, we started out looking at a battery-only solution, but one of the things that we wanted to learn was what's that direct interaction between the renewables and the batteries themselves.
Right.
So we looked at that.
So that, I guess maybe just so will the PV system, will that help to charge the battery? Will it work will you use it that way?
Yes, we will.
Okay.
Yeah,
It'll store the output of the solar system.
Yeah, again, it would depend on if the battery is going to require any recharging during daytime. So that's going to be the key question. Yeah.
Okay, thanks.
Okay, so we talked about that. So the main function of the battery is just basically to release the stored energy during the peak hours when we're hitting voltage issues to keep the voltage profile where we need it. That's the main function of the battery. The solar, when necessary, it will either charge the battery or assist with load reduction in those same timeframes. And that's part of the algorithms that we're going to have to be building into the controls as we get more information. Now, one of the weaknesses in the project is the meter data. Okay, a lot of our substations in these areas don't have the kind of meter data that we have in our urban areas. So we typically read these meters once a month. When we start to have suspected problems, we'll go put temporary meters in to monitor it. That's what we did for this project. We put it out there for about 30 days during the summer peak time frame we knew, so we could analyze, and that's what we built it on, was the summer peak time with the amount of meter data we had in the profile. The other part of this project is to put that advanced metering in the substation with some remote communication so we can be talking to this thing in near real-time mode. So that's one of the things you're looking at. We know what the load growth looks like when you're looking at your monthly meter reads. We can see that. That's easy. We've done that for years. But it's that more granular data that it's going to take to physically operate these systems at the most optimized level is what we're looking at there. So we're going to talk about here's how we envision the project deployment to do. We do need to acquire some property for it, and we need to get it permitted through the system. There are many government agencies that may or may not be involved depending on the piece of land that we can acquire. You know, the city, the counties, you've got, the feds may have a look at that. So there's several areas that we've looked at to solve it. We don't know how that's gonna shake out until we get right into the approval, so we can actually start talking to landowners and see if the land's available. We're gonna be contracting as soon as we can in January. The owner engineer who's gonna help us develop the RFP. Some engineers have done these for other utilities that know what they're doing in detail. They're gonna be helping us with the system optimization. We think your sizing's a little bit wrong. We think you ought to tweak it here. We kinda wanna leave that wide open. And then when we get the RFPs back, they'll help us with the evaluation of those.
Would the determination of what the ultimate project was have any impact on the land acquisition? I mean, do you think that's sort of a wash once you figured it out?
We're pretty confident with the land because we've done a lot of research. So we're looking at 5 to 7 acres that we need. I mean, there are some standard rules of thumb out there, so you know what you need to fit these into. And it's also going to be depending on what's available. I mean, we might find a piece of land that's 10 acres, that's the only piece of land available, but it's cheaper than what we estimated for 5 acres, so that's kind of like, yeah, we should do that. So, I mean, a lot of this is going to be done as we get into the project because it's going to be a very compressed time frame once we say go. We're not going to have the luxury of buying the land several years in advance, having it scaled out exactly, so yeah, it could affect it.
What does it need to be close to? Does it need to be close to transmission or resource, Rocky Mountain Power, you know what I mean? What is the engineering of where it needs to be located?
It needs to be kind of close to our distribution facilities.
Okay.
So as long as it's on, as close as we can to the distribution substation preferred, but as long as it's on one of my main feeders coming out of that substation, it'll help. So, you know, there's several main feeders coming out of a distribution substation. So if we can pick any one of those that has the right size, we can do that and interconnect it pretty well. And the piece of land we looked at are all adjacent to our facilities today, so you're looking at basically a very simple line drop to enable that.
Are all the parcels that you're considering right now, do you anticipate they'll require the federal EIS process? Because that can be quite lengthy.
Yeah. We're trying to stay away from that where at all possible. Most of the pieces of land we looked at do not have that requirement. Okay, so, but until we get right into it, we don't know. So that's why we got to leave it kind of arbitrarily wide open. Any others? Okay, and then once we get that RFP developed, we're going to go out to some, most of the major suppliers that do this stuff. We'll go out with the EPC, the engineering, procure, and construct. So they will do the detailed engineering. Part of the EPC is we're actually looking to say, we want you to not only build it, but we want you to operate it for us for a period of time as well. Because we don't have the experience on how to operate these things. How do you troubleshoot them? When you have a cell go bad, how do you know what cell? Do you need to be replaced or not? So we're going to be learning how to operate and build these things along it. So part of the contract will include some project life performances. This is what we expect to see out of it. And the maintenance agreements that say when something goes bad, your guys are going to help take care of it. So through all of that, we'll get those agreements in place. The contractor will be responsible for maintaining the construction schedules to meet the in-service deadlines that we need. So 2019 and 2021 is the in-service dates, right?
2017 and 2019.
2017 and 2019, okay.
Doug, what's unique about this project that requires that relationship? The company has solar farms around its system already, so.
We do, but we don't own any of them. So most of those are PPAs, where we just acquire the output. We're not responsible for maintaining the farms themselves or the battery systems. That's the big one, is the battery systems is what we're looking at, because we don't have any of those around. I mean, we got, and I'm glad this was before my time, we got the mothballed rattlesnake one that, you know, was, but we didn't learn much from that. So that's the difference. It's really brand new to us. Our crews, our technicians, none of those guys have got any hands-on experience with this. We're building the subscriber solar project now, so we're gonna learn some from there. But what we are looking here is not only the experience we'll gain from it, but the interaction directly with the battery. We can actually, if we need to, by owning the solar farm, we can say, look, just shut the output off, let's see what happens with the battery. How far can we ride this battery through a peak day without the solar contribution? Planning for maybe a massive storm system come through or whatever. So we can do some what-if scenarios by having ownership and control of these, working through the contractors. Okay, we want you to simulate this scenario for us. Let's see what happens with the data coming through.
And I noticed, just one other question that I've been kind of thinking about as we've been going through this. You said up front here, batteries are the best option for storage in Utah. Barring the problem that you're trying to solve here on this particular circuit, which I guess you're going to identify sooner or later. There are pumped storage projects around the state.
There are a few.
So how did you determine that this was the best option? Again, setting aside the problem that you're trying to resolve, which may require, from what you said earlier, proximity to the...
This is proximity to the load.
Yeah.
And if you look, I'm trying to think how to say this without saying it. We're a desert. I mean, Utah's a desert. There's not a lot of available water resources that are adjacent to a lot of our loads, especially in the rural parts of the state. So, you get south of Utah County down to the Arizona line. I mean, it's pretty tough to put a pumped hydro. I mean, there's other technologies like compressed air storage, that have some promise that are coming about. But when you're looking at how do we solve it today with proven technology that's been used in other places, we've kind of settled into the battery. So from our standpoint, that's how we made the statement. We thought batteries were the best option for us at this time. And yeah, it is site specific. There's not a lot of water available here. Anything else? So 3 major places we're going to look at the benefits. I mean, we're going to get the metering in place prior to the project coming online so we can establish some benchmarks. We want to see what the load profile actually looks like on a longer period of time. We can start monitoring the line voltage at a more granular data. This is the benchmarks that are going to be used as we put in the 2 stages of the project. After phase 1 at mid-project, when we've got the 2 megawatt hour battery in and the solar in, we'll go back once it's running and we're going to start benchmarking that against the initial to see are we seeing the benefits that we anticipated in the project or not? And if not, what do we need to do to correct that? And then we'll also have the one at the end of the project completion when we add the additional 3 megawatt hours of energy if needed to see what the total battery installation does, as also compared against the benchmarks that we established right before we started doing any of the other installations. Now, we don't believe that it's going to take us 5 years to say this is a good solution for other problems. We may start moving forward, but those other projects would come in as part of our normal capital planning as long as it's economical. This, like we said, it's a pilot. It's going to set the stage to get going down that road a little bit sooner than normally.
How big is a 2 megawatt battery?
Physically?
Many vendors that make 2 megawatt batteries?
I can take that. So
Ian's our battery wizard.
A 2 megawatt hour battery using current technology would probably take about a standard shipping container, so like the back of a semi-truck. Depending on what technology is selected, it could be as much as 2 of those shipping containers.
There are multiple vendors that make those?
Yes.
And is it literally one giant battery, or is it made up of a bunch of smaller?
Again, it depends on the technology. If lithium-ion is selected, which is the most likely, it's a lot of little cells, smaller than a AA battery, all put together. And they put those together into drawers, and the drawers get installed into racks, and then the racks are. There's a huge control system and battery management system that takes care of those as far as monitoring temperature.
How long does it take to charge?
So that's where the power component comes in. So it depends on the power conversion system that's installed with the batteries. And also, again, the technology, so in the case of lithium-ion batteries, they can usually charge a whole system in about an hour if they're going fast. But
They made up some sort of liquid cell.
yeah, so there are flow batteries, and they're, like I said, they're different technologies, have different charge rates, different lives.
I think one of the things that's important is the battery technology itself, the physical battery itself is not the magic in all of this on how you solve the problems. It's the algorithms and the controls that you put towards these batteries to enable them to charge and discharge as you need them to, not that they just do it on their own, because you'll run into all sorts of problems if they just decide, hey, I'm releasing energy here, because the resistance from the battery the system is lower and it can drop into there. So the control systems, like we said, that's kind of the magic to making sure that this works, making sure that when it sees a little variability in the solar or the renewables, that it can have the ability to discharge, to help firm that up very, very quickly, but not do a deep discharge when you're trying to do that. So you're looking at loading on the power transformer, you're looking at availability of power in the batteries, you're looking at what the renewables profiles looks like, and you're building this all into a model to say, okay, here's how we want you to behave, battery, so that we can, one, make it efficient and keep its life expectancy out there. The thing that kills the batteries physically is the number of times you take that into a deep discharge and recharge. That's what will kill a battery early, is if you're doing that cycling way too often. So some of the magic is try to keep that within some parameters of about 25 to 85% or something like that. If you can keep that battery in those parameters, you're going to extend the life of that battery as well. So that's some of the magic that we got to figure out here too.
Yeah.
How long do they last? I mean, will you get the same life out of the batteries that you get out of the solar panels?
So we're expecting about a 15-year life out of the batteries. Again, that will depend on the specific technology that's selected, and how it's used.
Is it fair to say that if you don't charge and discharge these too often, you extend that quite a bit further?
Yes, yeah, that's fair to say. And we also don't know what kind of O&M programs vendors will come up with. You know, someone might have low-quality cells that go bad quickly, but they might have an O&M program where they say, hey, as they go bad, we're going to replace them as part of your O&M program.
If you do go with lithium, what's the fire danger for these sort of large-scale projects?
Right, so that's definitely an aspect that we will take into consideration and build into our RFP as you know, something that we're going to evaluate. For lithium-ion, there are various subchemistries. Some of them are more prone to catching fire than others.
Talk to Samsung.
Right, yeah, so we'd probably stay away from the NCM, nickel, cadmium, manganese batteries that are known to have problems in that area.
Just on that, like one example would be subchemistries of lithium iron phosphate, which is kind of known to be more fire resistant than some other subchemistries. So those are the things that we'll have to look into as well.
And are you figuring 15-year degradation on your solar project panels as well too?
No, the solar panels, we're looking at 25 years.
Do ambient temperatures affect the performance of batteries?
Generally not, because the state of technology today for these large energy storage or battery energy storage systems, the systems are usually either shipped or designed to have a HVAC system to maintain the proper environment around the cells themselves.
So we put up here, these are all the informal questions we've got submitted. I'd like to go through these and make sure we've answered them. If not, we can dive into them a little bit deeper than what we had, so if that works. So the first one's talking about is the intent to have the batteries discharge every time the net line demand exceeds the threshold on an ongoing basis. So the answer to that is, it depends. Because remember, we've got a solar contribution here as well. So if the solar can help you with the voltage, when I'm starting to get through that voltage profile and the solar's taking care of that, we're gonna be okay. If not, the battery's gonna start releasing to keep the voltage within the bandwidth we need to. So it's kind of one of those answers that we're gonna figure that out through the RFP process, through operating it, but the intent is to basically rely on both systems we have in place at the time to help stabilize that voltage profile.
I'm sorry, this is maybe a foolish question, but what do you do now? I mean, obviously you've identified this problem. Is that a problem now, or is it one you just anticipate because of load growth?
Yeah, exactly. Right now, we're seeing, so we're allowed plus or minus 10% on a transmission system. This system here, what we do know, we're hitting 8% low. So we've got about a 2% bandwidth right now that we don't have the problem. But if the load growth keeps going the way it's going, it's about 1.8% per year load growth, it's going to push us into the 90 percentile in 2019.
I see.
So we will violate it at that time if we don't do anything different.
Thank you.
Can I ask you a quick question, Paul? You're talking you're violating voltage at the end of the transmission, or you're not dropping to like 109 volts on the circuit?
Okay, so what happens is you get two things that happen when you're talking about this. I'm going to tell you, it's a radial line. It's a radial transmission line that goes out, serves a single distribution substation. So the combination is I've got voltage control on the transmission and voltage control on the distribution system. So if I can keep the transmission within the plus or minus 10%, at the distribution level, I've got to keep it within plus or minus 5%. So 114 to 126 volts. So the combination of the two, if my transmission is down to 90, my regulation on my distribution system won't be able to buck it up far enough to gain that other 5% to keep me at the bottom end. So that's why we're looking at it is, it's not the distribution system. If I'm at 100% voltage on the transmission line, my distribution system doesn't have a problem. We can correct that, but it's my transmission lines pulling the distribution down. And that's where the actual effects of the delivery you're seeing are by the distribution customers. To help?
Yep.
Okay. Okay, I think we talked about the useful life of the batteries. Okay, it talks about, Exhibit D discusses the need for load shedding and load transfer schemes to be developed. So, I mean, this is a safety, operational reliability kind of a question. We did not account for those in the budget because typically we do those programs on a case-by-case basis as they show up, and those costs would just settle into our normal engineering costs as we design those programs. So we actually believe that in this, what we tried to do in the project is we tried to identify all the anticipated benefits, whether you'll realize those all or not, if we're going to find out. What are all the anticipated costs that are directly related to this? And we didn't see that load shedding was a cost that because like I said, we're at the end of a radial line. The line itself has capacity on it. So if I get into an emergency condition, there are ANSI standards for emergency operating conditions that we can very well maintain even at the state without the battery if we get into an emergency system. So I think we're okay that way. So we don't anticipate that with this program, but if we need to, we'll just develop as we do with all our other circuits. Any other questions there? Okay. Who do we have? Is Doug Locke, are you on the line? Doug Locke's based in our Portland office. He actually took care of all the tax questions on this. Me, I know how to spell tax and I know how to pay it, but other than that, I don't know the answers to this directly.
Is he on the,
I don't think he called, so maybe we can call him and see if we can get him on the line and come back to that. Thanks. So any tax-related question, we'll defer, and then when Doug gets on the line, we'll come back and answer that. So that takes care of number 1 and number 2. Number 3, have sites other than the one proposed in the docket with potential voltage issues been considered? This was actually the only site that we had that had a voltage issue. when we were looking at it. We had a couple others that had some loading issues, thermal loading issues, but the benefits gained with battery on those were very short term because of the load growth in the area, so we didn't see those as being economically, this was the better one to choose for a pilot, so we can study both voltage issues and peak shaving if we need to at this site. So that's how that site selection ended up. Blue Sky program funding, I don't think we have the person here, that was...
Jason.
Yeah, Jason, I thought Jason was going to be here. Chad's going to join us soon, he's at another meeting, so Chad Ambrose can speak to that when he gets here. Number 5, it says that the technology has been decided upon. I think we use lithium ion in the example because most of that was pretty standard. We have not decided on a technology. That'll be decided through the engineering and the EPC program to say exactly what we want. What we do know is that the footprint for most of these different solutions is about the same. So the acreage that we need would be agnostic of the actual technology selected. Okay, please explain how the company intends to report the results of its storage RFI to the regulators and other interested parties. We will do that as required in the Utah step legislation, pretty much.
I don't think there's any
So who had that one? Oh, yeah. Who wrote that one?
We did.
Oh, no, I'm sorry, no, not the question. The answer, oh, it was Irene, huh?
I think Irene's wrong.
Yeah. So in the, oh, I know what it was, it's the application, I misspoke. In the STEP application, we said that we would report this back no later than October 31st of 2020. Irene, are you on the phone?
Yes, I am. I was just trying to get a hold of Doug Lock and Jonathan Hale.
Okay. So do you have anything to add to that question about how the company intends to report the results from the RFI and RFP to the regulators and other interested parties?
My understanding at this point in time, the plan is for us to report back by October 31st of 2020 to meet the requirement where the commission has to report back to the legislature for the session of the legislature starts for the 2021. So that's our intent currently. And I don't have any interim targets with regard to reporting at this stage, and I am not certain what folks are looking for, to be honest, with regard to interim reporting, if there is any that is like.
Does that answer the question?
Well, I kind of knew that, but I was hoping we did a little bit more often than 4 years.
Okay.
Might be something you have to request.
We might have to request that later on.
Okay.
I'm sorry, I can barely hear.
Sorry, Irene, I just said that might be something they have to request.
Within all of the STEP programs, what we are going to be doing is we are setting up an accounting structure where we're going to have all of these costs identified by project, and so we can give reports on that. And if there are questions on this at any time, you know, once it's done, we would be more than willing to meet with the parties and discuss the status and what is being done.
No. Probably not.
That's fine. No.
You may
Okay.
want to follow up.
We will follow up.
Yeah.
Well, I think the point is we've had a couple of meetings already on STEP, and the issue of reporting has come up before. We can either work something out, or we can make recommendations and testimony.
Right.
Of what we think is appropriate reporting stages.
Right, and we're more than willing to work with parties to come up with a process, you know, because, like I said, we will have the details of what's done, we will have those in reports, and so, you know, some of this I think might be done better verbally if we bring in, you know, if you want to hear the status of this project, then it would be Doug or others, but that's something that we're willing to work with the parties to come up with something that will work for everyone.
But let us know what your thoughts are in terms of what.
Yeah, as we move forward in the docket, we will.
And I think, as Steve suggests, that, face-to-face, technical workshop meetings are a good forum to convey this kind of information rather than, responses and reports and that sort of thing. But whatever works for you.
Okay. We'll move on to number 7. What is the process for acquiring the services of the owner engineer?
Okay, so the plan right now for acquiring an owner's engineer is to put out a competitive RFP to companies that, to multiple companies that we know have expertise in the integration of energy storage and renewables. Like Douglas was saying, the important piece of this project is the controls. How do you dispatch the energy storage in relation to the load curve and in relation to the photovoltaic generation. And now that RFP will be finalized, the development of that RFP will be finalized and it will be released upon approval from the commission.
And the second part of that is how do we intend to report it? I think that's answered. Okay.
Well, another question that just kind of occurs to me is, under a major plan addition, the commission can hire an independent evaluator. Are these all exempt from that statute, or? Daniel, I don't know if the company has thought about that.
I have not, but I wonder if it meets the dollar threshold.
Yeah, that would be the other question there.
The major plan addition statute currently states it has to be around 1% of rate base, which is over $100 million.
So these are well below that.
So
okay,
these are well below that. The total budget for this is well below that.
But there's the part for the renewables. Not the major plant addition, the renewable portion of it. That's a good point.
I
don't
know what
know.
you're referring to.
There's with the major plant addition, they carved out the renewables. So we get a consultant, not an independent evaluator. So that,
I don't remember that. Would have to look into that.
yeah, it's section 602 or something like that.
Number 8, we're back into did we get all of Doug?
I sent an email.
Okay. We'll just wait to hear from him. I'm just tracking this. Number 9, please come prepared.
On number 8, I was just trying to read it. Okay. Basically, it's just like, on your depreciation for the solar assets, they will be treated just like what we do for any of the contributions in aid of construction of kayaks, where, where it's paid for out of funds. So the net plant is always at 0. And that kayak flows through taxes, and this will flow through identically. I'm not sure exactly who asked the question, what details they wanted, but that, at a high level, that's the exact same method.
We'll keep that open, so if there's anything additional Doug wants to add, we'll keep that one open. Okay, so number 9, please come prepared to discuss in more detail the OMAG cost for the storage and solar projects. So Ian?
So like I said earlier, the O&M costs, we don't know exactly what they'll be yet until we get proposals in hand. we estimate there'll be around 20,000 per year for the energy storage component and around 20,000 per year for the photovoltaic piece of the project.
Could you repeat that? I'm sorry.
So I expect the O&M costs for the the storage piece of the project to be around 20,000 per year, and also 20,000 per year for the photovoltaic portion of the project.
And that 20,000 is the initial battery. When we add on the additional 3 megawatt hours, the incremental portion of OMAG is very, very small. Okay, so it might push it up $500,000 a year, but it's not significant when you add the next one on, as far as we can estimate, right?
Yeah, and there's some interesting dynamics there with the energy storage, and that as you put in a larger energy storage device, it doesn't get used as heavily, as deeply, as quickly, and therefore it has lower degradation rates, because those O&M costs for the energy storage piece have the degradation built into them.
Good on that one?
Doug's on the phone, Irene's gonna go upstairs, so she should be right.
So it sounded like somebody joined or left. Doug, are you on the line by chance? Assuming not, okay. We'll keep checking.
Irene's going to see if she can find them on the board.
Number 10, I hope somebody can answer this one. Please provide a copy or an update of the overarching Utah Step County document.
I can handle that. Basically, that is in a finished state. It will be filed. Our goal is to file it by Friday. What we're right now doing is putting together some testimony that happens to be under my name on the accounting for the STEP program, and that will be an attachment to that testimony that I have started to type up, but I need to finish. So once I finish it, it will be filed. I've been told by the company to try targeting to get that filed this week. So.
Okay. Number 11, this is going to be Ian again. As part of the enable a greater understanding of these innovative solutions, have we determined how the panels are going to be disposed of at the end of life, and was this calculated in the financial analysis?
So no, it was not calculated in the financial analysis. We expect that to be a small cost. On the energy storage side, some of the suppliers of energy storage systems do have built into their cost the end of life, either recycling or retirement of the systems. For example, one of the flow battery companies that we talked to, they will take back all of the electrolyte from the electrolyte tanks and reuse that, and they'll take back the entire system and recycle it.
And just to add to that, we'll be getting a lot of those information once we go out with the RFP process, so that's something we'll get some information on that.
Does that answer that question?
So, yeah.
Doug, this is Irene Hing. I've also got Doug Locke here with me currently.
Great. Welcome, Doug.
Hey, guys. Jonathan Hale, I think, will be joining us shortly, too.
Okay. So we're going to back up here. There's a couple of questions we needed you to address. So I hope you've got a copy of all the questions, because you provided the answers. So,
Yeah, we think through them.
okay, from the Utah DPU, questions number 1 and 2. So number 1 was, what are the investment tax credit disadvantages for IOUs? So if you want to talk to that.
Okay. kind of big picture on normalization. Congress was passing incentive programs to encourage taxpayers to make capital investments. And those incentives included the investment tax credit and then accelerated federal depreciation, including bonus depreciation. And that resulted basically in upfront cash tax savings on the current tax expense to investor-owned utilities. And in the absence of the normalization provisions, commissions were requiring the utilities to give all of those incentives back to customers. So Congress felt that violated the purposes of the incentive because the investor-owned utility was disincentivized from making investments because they couldn't retain any of those benefits. So the solution was normalization. Basically, that prohibits investor-owned utilities from passing the benefits from ITC and accelerated depreciation back to the customers faster than the book life of the project. And so, through the mechanism of how Pacific Corp does it is basically, to the extent that there's a deferred tax liability on accelerated depreciation or give back liability for investment tax credit. Those are rate-based reductions, and that rate-based reduction is amortized over the life of the project. In this case, I think we're using 25 years for the solar life. And so the result of that, approximately, on a present value basis, the utility shareholders get to keep about half of the benefit of the ITC, and the customers get about half the benefit of the ITC through this normalization process. Now, if you're not subject to rate regulation on a rate base of return, then an independent power producer, they're free to price their electricity however they want, and they're not constrained by limiting passing these benefits through so that the customers only get 50% of the present value of the cash flow and the shareholders get the other 50%, keeping roughly a big picture. So they're able to, negotiate and with customer through, a purchase power agreement, and they can pass that upfront ITC 30% cash flow savings. If they want to, they can give that all to the customer upfront. So that's essentially why investor-owned utilities are constrained on, passing that ITC through to customers. Independent power producers don't have that constraint. So they're generally conceded to be in a better pricing posture.
And you want to keep expanding on that, because the next question is, what other resources are available to RMP to help pay for the solar facility, i.e. tax incentives, grants, etc.?
Well, the big incentives are bonus depreciation, 5-year makers depreciation, and ITC. Those are basically the major players in the renewable business.
What was that middle one?
5-year makers.
Federal makers, 5-year makers depreciation, and right now we're having 50% bonus depreciation. It'll go to 40% for projects placed in service in 2018, along with the 30% investment tax credit. And the customers share in all of those benefits. Just, there are constraints about how much they can share in them.
And the other part is, for the total project, we're actually using some blue sky funds to reduce the impact on the STEP funding. So the blue sky funds being used for the solar. So I guess that would be another resource of.
Given that it's related, do you mind if we skip to one of the questions I asked?
No problem.
About if you've evaluated the economics of the project, sort of assuming utility ownership versus third-party ownership.
Question number 4, right?
Yeah,
So I've got that on the
3
screen.
and 4, I think.
Okay, so I'll let Doug, but on number 3, if we examine the cost of third-party ownership, one of the things we were looking at was, as we said, it's a pilot project so that we can say, if we own this, we can control it. We're not driven inside this to maximize the revenue flow back to the owning facility. So if a third party owns it, they're going to want to maximize. And I think you've seen those issues arise now when you have competing renewables trying to be produced, pressed into a market that has no demand. So, they're driven by that. So we opted to go with the ownership for that reason, so that we can manage this thing the way we see best to get a full understanding of the spectrum for both controls, operation, what happens in emergency states. So that's why we didn't look at third-party ownership on the solar system. So.
Right, I understand that the issues, I mean, there are motivations for doing company ownership. I just, I think it's sort of a separate issue in terms of just evaluating the economics to look at this. So that's why I was asking.
Okay.
And this is, excuse me, this is Sarah. Sarah Wright. I didn't introduce myself earlier. I was streaming, but so I was just wondering if you evaluated, as a follow-up to Sophie's question, if you've evaluated working with a third party that might be able to do the accelerated depreciation and then maybe a flip to the company after the 5 years accelerated depreciation and the economics of some different structures.
I'm going to look for the tax guys to answer that one.
So kind of like a build, own, transfer
Exactly.
project?
Okay. Doug, did you get that question?
Yeah, and we've looked at that, but there are some real risks on basically having somebody own it and take all the tax incentives, and basically maybe through a reduced purchase power agreement, then basically us having a wired-in deal to buy this thing after the 5-year tax credit period is expired and the property is fully depreciated for tax purposes. And generally, the risk of being not deemed to be a tax owner has basically constrained our desire to engage in those projects. And most of them have ended up being a longer-term PPA and not simply a 5-year rolling deal.
Okay, thanks for that answer.
Okay. So I think that took care of 3,
But I
4,
completely understand that, but I do have a follow-up question from earlier. When you were explaining the difference in the PPA price and the company ownership price, you said that there was, independent power producers were able to do it at a lower energy cost, PPA cost, than the utility could provide. I was wondering what order of magnitude difference it is. Is it 15% or 10%?
I'm looking for the finance guys to ask that one. I don't know.
There's a whole variety of issues that would come in, such as what rate of return they want, and a whole bunch of issues other than taxes that impact that decision. And I think those are more, I don't want to get into arguing a position here, so I would rather just state there's a whole variety of issues that come into that kind of a decision, and we have to look at all of those issues together.
Okay. And we just need to get a better understanding of this for this case, but also for the integrated resource plan and other areas where you're modeling utility ownership. And not that I'm against utility ownership, I just think we need to look at all the options.
Agreed. But like I said, there's a whole variety of issues, and I don't want to advocate for one position here in this. technical competence.
Thank you.
So Sophie, that took care of 3, 4, and 5 for you. Can you check those off?
Well, yeah, so with 5, I think, you're just saying, I think my understanding is that, your desire is to essentially gain experience with ownership.
That's our
and-
biggest thing.
And operating it. Yeah, okay, yeah.
Okay, so we're gonna skip back. Let's see.
I have one follow-up question
You got
on the ITC. I just want to make sure I understand. So you're going to use blue sky funds to purchase most, or as the capital, for the capital cost of most of the solar PV system. So the company will still be able to take advantage of the ITC, is that correct? And then...
We're having trouble hearing you.
Yeah, you're gonna have to.
So you're going to use blue sky funds to, for the capital cost of the solar PV system? Does that, I'm just trying to understand, will the company still be able to take advantage of investment tax credits and other tax advantages going, funding it through that scenario? And if you are, do I understand correctly that 50% will go to shareholders and 50% of the benefits will go to customers? Kind of 2 parts to my question.
So, actually, your question actually dovetails right into the number 8 question that we were just getting to. So I think we can expand on that. So Doug, we're looking at the DPU question number 8. And then the question was a clarification of how the ITC benefits get worked between the company and the customer.
And if the company is able to use the ITC benefits in this scenario.
So, the extent that the blue sky funds are used to purchase or buy down the cost of the solar facility is that for book purposes, the revenue generated from the blue sky tariff is not included in book income. And it essentially ends up in a regulatory set aside, which is then used to purchase the solar facility. Accordingly, there's no rate-based solar facility, so there's no rate of return to the utility on the book side. On the tax side, kind of a general rule is to the extent you get cash for something, it's generally going to be taxable income up front, regardless of what you may have as future obligations. So accordingly, these blue sky tariff monies end up being reported as current taxable income on our tax return. And then when we use those funds to buy the solar facility, since we pay tax on that cash, we get taxable basis in the solar facility. Therefore, since we have the taxable basis, you get the investment tax credit and depreciation on the facility for tax.
That's good.
And then who benefits from those tax incentives, benefits? The customers versus shareholders?
Did you hear the question was who benefits from that ITC, the customers or the shareholders, or both?
Both.
Can you explain how that works?
I think the best way to explain it is, so as far as I'll break it into 2 pieces. As far as the tax depreciation, those benefits are all going to the customer. There is a deferred tax asset associated with that, the tax basis is greater than the book basis. So that will be a rate-based item. As far as the ITC goes, and that's just like any other tax depreciation item that's on our books for rate-based purposes. As far as the ITC goes, as Doug mentioned, there is a sharing between the customer and the shareholder. because of the normalization provisions out there. And the way that works is that the that deferred ITC goes into rate base as a rate base reduction. And that rate base reduction amortizes down to zero for the book life of the asset. So each year that rate base reduction will be a little bit smaller until it gets zero by year 25. The customers are going to receive that benefit of that rate base reduction over that 25-year period. However, the actual ITC itself that was received from the government will flow to the shareholder.
Thank you. Okay, great. All right.
I have a follow-up question, if that's all right.
Yep.
I'm sorry to be so froggy. So when you say the customer, what do you mean by the customer when this is blue sky money from customers that are in a voluntary green pricing program?
When I say customer, I'm just referring to those individuals or entities that are receiving the energy from that solar project.
Is it fair to say it's basically all of our Utah customers?
If they're all receiving the benefits of it, yes.
Yes.
So I have a follow-up question on that I don't think made it into Utah Clean Energy's questions. And I'll cue it up now, and perhaps you can answer it when it's the correct time. So this is blue sky customer money, and it is paying for a solar project or buying it down. I think we'll find out more about that, or I might have missed that when I was switching over from phone to the streaming. But given that blue sky customers are paying, in the past they've paid for community projects, and so that solar has been built in their community and serving organizations or entities that the blue sky program deemed viable or good options to get this power. Seems like anything that's funded by blue sky funding, the energy should be somehow earmarked or through a grant program go to community entities in need, food banks, homeless shelters, low-income citizens, something so that those that are paying the money, and the blue sky money obviously is far, far more than the RECs, the cost of the RECs that they are in theory buying. And we did put this in our notes on the blue sky, our comments on the blue sky program, and I'm just wondering how the company is thinking of dealing with that energy and the equity and the fairness to blue sky customers.
That is in our questions.
Oh, sorry, I missed it, Sophie. So you can answer that whenever it's appropriate, but I just wanted to make sure I queued it up.
It's in the UCE's question number 6, so we'll be there in just a sec. Okay. Okay, so continuing on, we're down to question number 12. 4 was Chad Ambrose, we were waiting for him.
Oh,
He's not here yet, yeah. Chad is actually physically in Salt Lake. He had another conflict and he was going to join us. He thought he'd be here about 2 or 2:30 time frame, so I think we'll get to it. Yeah, thanks for catching us on that. Okay, number 12 on the financial analysis chart, we talk about property cost and owner's engineering cost. What we do is we're putting feelers out for the land cost. That's how we came up with a $100,000 cost. We went to our project management group. We said, this is what we're trying to do. We need a budgetary estimate for this of what we think it's going to cost to go through all the owner engineers. And they've done this for other projects, but not battery solar. So they actually gave us a pretty wide range. And we said, well, we need to nail this down. So they said, well, put it around 400,000. I mean, that ranges from 300,000 up to 700,000, depending on different variabilities. So they said, well, we're pretty sure we can do it at 400,000. So that's how that was put in. it was a budgetary estimate coming from our project management group to say, what do we think it's gonna cost us to pull this off through that? Okay. Number 13, I think we've answered that. It's similar, how are we gonna report progress on all this? So, kind of similar thing. So, Utah Clean Energy's questions. Number one, what's the estimated cost per kilowatt? We just took the estimate, divided by the kilowatts, it comes out to be $3,000 per kilowatt.
That's why I asked the question, because I did that math and that was really expensive, so I thought I was wrong, so.
Well, yeah, it's a budgetary estimate. As engineers, when we put together programs, we want to make sure that we're conservative on our estimates, so that we can actually bring them in less. We think the RFP is going to drive that price down. Personally, I didn't think it was too far out of realm, but it's a little high from what I expect. Well, it depends on, we're doing kind of a small plant.
Okay.
In a very remote area.
Okay.
That's, so it's like, okay.
So you just wanted to outside
what's the demob cost for the construction crews? What about transport of materials? We were a little nervous about make sure we account for that. Because I'd hate to come in and say, well, we can do it for $1,000, and we walk back in, it's $1,800.
Sure.
That's worse than saying, hey, look, it was $3,000, now it's $22,000.
Okay.
So that's really what that came about. The annual output, I thought that was in the documents as we looked at it. It's not. It's about 1,024 gigawatt hours or megawatt hours a year. 1,024 megawatt hours on an annual average. That's an average annual, based on, we used NREL's PV watts calculator to do most of our modeling.
Okay.
And this came for a single axis project.
Single axis, okay.
What kind of capacity factor is that?
What's that?
What kind of capacity factor?
When we designed when we looked at the project, like Douglas mentioned, we use NREL's PV watts. It's publicly available software. And in the losses section, you have soil losses and different losses. We use 14% for the losses, and then the software comes up with the annual energy production with that project. So that's how we came up with the 1,024.
I can calculate it myself. I just thought maybe if you knew the number off the top of your head, what that was, like 20%, whatever. It's probably around.
I think it was around that, but we'd have to go back and look at all. I did that several months ago. It's a lot of inputs that went into that.
Okay. So we got 3, 4, 5. So 6, I'm gonna tag that for when Chad gets here. He can talk a little bit more of the blue sky.
Okay.
Because that's similar to the number 4 question above for the DPU. Okay, will the proposed project have benefits on the transmission system? So.
Yeah, I think this was explained by Douglas in his presentation as well. So what we're trying to do over here is using peak shaving at the distribution system. We're trying to offset the load so that it has an indirect benefit on the transmission system upstream of the distribution system. So that's where we're saying, okay, using the storage connected on the distribution system, we're having voltage improvement on the upstream transmission line. So that's kind of the benefit that we looked at for the transmission line that's kind of connected to the distribution system. So I don't know, does that answer the question?
I think the other thing is, the benefit is the transmission system doesn't need to be replaced.
Yeah, well, it seems like a clear benefit. I just, I'm not super technical, so having it spelled out is helpful.
No, that's a good question, yeah. That's a good question.
Then number 8 is describe how the company is evaluating transmission level impacts.
So we have a software called, it's from Siemens, it's PSSE software. That's what we use for all our transmission studies, be it, 345 kV or even, smaller level transmission systems. So that's a software that's going to be used to look at, okay, if there is any engineering impact on the transmission system and what kind of impacts are going to be. So.
Okay.
And number 9.
And that number 9 is just, it's straightforward no.
Oh.
If it's a FERC thing, no.
So what's the voltage on the line?
Well, let's just say it's lower than FERC. And the reason I'm being a little I know it's in the confidential documents were filed with the application,
Okay,
and I will tell you, it's not a broadly used voltage. We're just trying to make sure that nobody tries to up the prices of property when we go to get it.
okay.
I mean, based on some of this information, if you get our system maps, you can probably figure out pretty close, roughly. I don't think they will, but if you want to grab me afterward, I might tell you.
Okay. Well,
And
yeah.
then he'll have to kill you.
No, that's.
No.
No, I mean.
She's the only one that sends me an email that
You don't own property there, do you?
Yeah.
You don't own property there, do you?
Yeah, no, I mean, I have no idea where this is. It's in your backyard, what are you talking about? No, I mean.
Go ahead, play dumb, that works.
And I mean, I don't know, I mean, I don't really want to get into issues, but I feel like, I mean, this is a pretty cool project, you know, and there are, since Order 1000, the utility has opportunities to bring this type of project into transmission planning processes.
Right.
The cost recovery is still sort of a tricky issue under Order 1000, but I'm just wondering if this is the sort of thing where you feel like you need a special dispensation from the Utah legislature to go after a project like this, or if this is just sort of an initial pilot, as you say, and to get your feet wet, and then as these opportunities continue to arise, you'll keep considering non-wires alternatives. And so that's sort of, I'm trying to get at those, I'm just trying to explore those issues.
Yeah, so trying to answer that in the broad context, we actually started this a few years ago, and myself, Rohit, and a couple other guys were very deeply involved, and we actually have developed planning templates now that our transmission and distribution planners use. And one of the first questions that they're asked to do now is to analyze non-traditional investments, because we want to get that into their mindset. Right now, when you do just a straight economic comparison, we have not ever found that it's cheaper than a traditional investment. So not being cheaper, it raises our prices, and we don't really want to do that. But we know this is coming, we know the prices are going down, and would hate to get there the day to say, hey, we need to throw a battery in, and we have no idea how to do this. So this is kind of a lower cost option. From an initial capital outlay, it is cheaper than the other options. If you run the numbers all the way out, I mean, you know, how long does a transmission line last compared to a battery? You know, you get into some economic considerations out there. So this is kind of a first foray, and it seemed to be a very economical one for our customers, so we can get that experience without a lot of cost. So, and it just happened to be in a good place, and yeah, so we do have that. It's in our system that they do have to look at DER, we call it DER, Distributed Energy Resources. They do have to look at DER as part of their overall planning analysis nowadays.
Right.
So I have a follow-up question to Sophie's question. So this transmission line on which you're solving this problem is not rolled into the company's formula rates, rates? It's not in rate base?
Transmission line is, yes.
It is. So it is FERC jurisdictional.
Well, the FERC jurisdictional is define things based on load serve, pathways, and a lot of other issues. I'd have to get our transmission guy to come in. We went and we said, is this, and he said, no, this is not considered. Remember, it's a radial line. It's not a very high voltage transmission line, I'll tell you that. Because in some parts of the country, they actually consider this transmission line a distribution line. That's how low the voltage level is.
I think there's a 7-part test that.
It is, there is.
Right,
Yeah.
and this one does not meet those.
The test for what?
On whether or not it's a FERC jurisdictional line or not. It's not just dependent solely on voltage.
But it is rolled into your FERC-approved formula rate?
Oh, I didn't hear FERC-approved formula rate. I thought you
That's
just...
what I thought, yeah.
Oh,
Your
no, I thought you were just
open
talking...
access transmission rates, is this included in that calculation?
I don't know for this particular line, but my guess would be no.
So it's just in your rate base?
Yeah, that's what I thought you were talking about, just a rate base.
Can you get somebody?
Likewise, I'm not involved in our FERC transmission cases. I know that some plant is in, some is out, so I can't say whether it is or not. I do know it is in the transmission function. The radial line going into the substation is in the transmission function for our rate cases, but whether it's in for the FERC OAT rate, that I do not know.
Could you follow up and find out what it is?
The best would probably be to ask a formal data request, and we'll have them research it. I'm not sure how easy it is going to be for them. You know, we'll have to do some research on that.
Should be pretty easy to find out.
Yeah.
Yeah, I don't, like I said, I'm not involved in that process at all.
We just need to focus the right people on it, Bela, and if you'll send a data request, that'll help us do that.
I'd take odds on the answer. So, all right.
So would I, but I would rather have it for the people who actually know give the final answer rather than what I think.
Yeah. Okay, number 10, provide an analysis, any analysis the company has quantifying the value of the distribution and transmission system impacts resulting.
So, in the Exhibit D, there's an appendix to the study, and what we did is basically we put in all the results of all the analysis we performed for different scenarios. So you'll have all the information available in that appendix section of Exhibit D of the filing. So, and I think I already went into some of the details of how we decided on the battery versus battery plus solar when I answered one of the questions back when Douglas was presenting. So the breakdown of the results of the analysis is already provided in the appendix of the exhibit. So I don't know if you have any detailed questions or other questions on that.
So yeah, just remember, a lot of the analysis is done with limited data. You know, we got an issue, we know the issue, and we've done some limited analysis to say what do we think it looks like long term.
Right.
Does that help? Anything else? And we got one more. This is your review. So this, the program benefits Pacific Corp transmission system. Please explain how non-Utah or non-retail users of the transmission system will help cover the cost of this program. So,
Yes, as has already been discussed, there's some analysis that shows the benefits. However, when we're looking at allocations, there's a few things that we have to take into consideration. One, this is on the distribution side of the substation. By definition, everything on the distribution side is situs allocated. Number two, even though it's situs allocated, we're paying for it with STEP funds that were authorized as an experimental program, and as Doug has said, this is really a pilot program to get to get the experience, to get the operational benefits. And within our allocation process, it talks about jurisdictional specific initiatives, stating how those jurisdictional specific initiatives are situs to a state. So under the allocation method, both because it's distribution and because it's a pilot program under a jurisdictional specific initiative, the costs will be borne by the STEP program. They are not being allocated to other states.
does that take care of that one?
Well, I think there's still an open issue there. Section 10 of the protocol talks about both costs and benefits being situs assigned under state initiatives, doesn't it? And since this does have transmissional benefits, how do we ensure that all those benefits are following the cost?
Let me kind of, from an engineering standpoint, when you look at the voltage problems, and I correct the voltage problems, those are benefits to all my distribution customers at the end of that line. And it really doesn't do a benefit to the transmission line other than saying, I don't have to change you out.
Right,
So that's, when you talk about pure benefits, is that a benefit to the transmission line?
I don't know, and that's why I
Or is
said,
that a
I
benefit to my
think
customer
there may
system?
still be an open question about the interjurisdictional allocations.
Right, and section 10 actually is talking about direct access. This is actually under section 4.
Okay, section 4.
But, you know, a lot of this is to find out what benefits there are, to find out what can be done in this area. And so, like I said, it's being paid for with the funds that were authorized for these pilot programs to get the background, to get the knowledge, to gain the experience. And that's why we're using this and we're funding it through the STEP because, as Doug stated, it is a little higher cost. It is sort of a pilot program that we're just trying to gain that experience to figure out how can this be better used.
I have a question, Doug. So if the transmission, replacing the transmission line, was that 8 million Citus assigned to Utah? Or is that the total project, so it would be broken out between other states also?
Okay, so that's a question that the tax and the rate guys got to answer.
No,
Well,
you.
Could you repeat the question, please?
If we replace a transmission line, then that is system allocated. And so it's something that comes up all the time, which is what options are there? And there's several times where you have options both on the transmission side and the distribution side. Under allocations, transmission are allocated to all state. Distribution changes are allocated situs to the state where it's located. It's just...
So transmission, was the 8 million for the transmission line, was that Utah's Citus? Or
No, he would have been referring to how much it cost.
Total.
Total.
That's my capital
So
cost.
Utah's percentage would not be the 8 million, it would be 4 or
Roughly
5.
43%, 44%.
So in the long run for Utah,
Yeah.
Well, that's the issue that I see under interjurisdictional allocations that we'll have to think about is companies choosing to do a distribution side fix that is saving system transmission costs.
And at the same time, we're choosing to do a pilot program to get
Right,
that
yeah, I understand.
experience. So,
Yeah.
yes, you're right.
And it's not just the 6 states, but it's also the wholesale customers.
Right.
Would also be sharing in the costs of any transmission.
Certain transmission, yes.
So let me ask a question. Now, remember, I'm an engineer. So what would, if we spent the 8 million, what percentage of that would settle in Utah?
Roughly 43%.
And we're looking at the battery system here, so you're looking at, what, 32, 33 million? 3.2, it's 3.2, 3.3 million.
32
Yeah.
million. Wait a second.
Yeah, I forgot a decimal, 3.2, 3.3 million, right? Versus a battery system that's how much, did we say?
4 to 5.
4 to 5, so that's what you're looking at. So,
Yeah, we'll just have to think about it.
yeah. So that's all of the submitted questions. I don't see Chad, I don't know where he's at on the blue sky stuff. So I'm kind of at a dead, I mean, I can give you what I've heard discussed, but it's not an official answer. So I'm not sure I don't want to do that, unless somebody else knows a little bit more about blue sky than I do.
Which question was that?
So it was DPU's question number 4, and we also had one in UCE's.
6.
Number 6. So,
should we ask them an official data request?
yeah, my understanding is we try to get all questions answered, get everybody on the same page, and then everything from here on is data requests. So, Blue Sky program funding of the solar generation facility defined is what is meant by buy down to competitive rates. So that's kind of the one that's outstanding there. And then we've got UCE's number 6.
So does that, in your budget right now, the Blue Sky programs won't pay for the entire PV system, right? The company would have to make some investment, is that right?
Do you remember how that went?
The whole thing.
Oh, yeah, I thought they paid for the whole thing.
For the
Oh, they pay for, okay.
Except for the land, right?
Yeah.
Not the land.
The land.
Not the, good. So I think we're kind of at a stalemate on the blue sky questions. I apologize. I mean, so that's kind of everything we had presented. Those were all the questions that were submitted. I mean, we're wide open for any other questions. We've got a team here. We can answer them, yeah.
Additional question. I've been having a little bit, as I read through it, file tracking the 8 megawatt hours versus the 5 megawatt hours, and is it a fair assumption that the 650 kilowatt solar replaces the 3 missing megawatt hours, or is that?
That is the right thing, yeah. And that's why we did the analysis, to see, okay, how much can we reduce on the cost piece for the battery, because the batteries right now at least are pretty expensive, so, and how much the solar can offset, and especially, in the daytime, it makes a lot of sense to use the solar as well. So that's where the solar really helps to kind of reduce the size of the battery.
And then, one quick follow-up to that, the reason that didn't transfer through to just going 100% solar, is that the result of some of these peaks being after the solar?
That's correct.
Hours?
Yeah.
And actually on this place, those outside the hours peaks are both morning and evening.
Okay.
So we've got to make sure that battery's ready to go first thing in the morning, so we can pick up those morning hours. Then the solar's going to start helping us out, and then the battery's going to ride us through the evening hours.
Yeah. And again, what we used is basically, we again use a PV watts model. The reason is because we don't have, absolute clear solar installation data, measurements taken by real time by anyone. So we used the PV watts model. We used the solar using that. We used the lithium-ion charge discharge rates and all those kind of things. And then we designed the model and figured out, okay, how much solar do we need and how much battery do we need? Because end of the day, what we are requiring is the energy piece, if not the absolute demand. We're looking at the kilowatt hours, the megawatt hour piece. So that's how we designed the battery for that 1 month of data that we already had.
Are there any other questions? Okay, well, thanks everybody for participating today, and we will have one more technical conference on this a week from today, I believe at the same time.
That's on the clean coal
Right,
NOx.
the neural network project and the NOx project. And then on Monday, in the same docket, there's another scheduling conference for some of the things that will be in phase 2, I believe. So, with that, we'd like to conclude, and thanks everybody for their participation. And we'll see you either Monday or Tuesday or whenever. So, thank you.
Thanks.
Bob, would you